So first I would like to discuss what do you mean by a vapor pressure. Do you have an idea about vapor pressure?
Sure.
I'm just giving you a simple example. Suppose you have a container and some part of it is filled with water and it is a closed container. Okay. And here water you have taken. Now you know that uh, even if you take water and keep it in an open space, suppose on a table, what do you find in the level of water? What happens to the level of water?
It may increase.
It
It may increase.
it decreases, no? Because water gets evaporated from its surface, isn't it?
Okay. Yeah.
If the water
If you leave
gets
it open.
yes, evaporation
Yeah.
takes place. That is the reason level of water decreases.
Hmm.
It will keep
Okay.
on decreasing, and once upon a time, maybe 2-3 days after that, you can see that there is no water in the container, right? Because that is an open container. But if it
Yeah.
is in a closed container, then what happens? First, you can see that there is a decrease in the level. Then after decreasing the level, after there is a decrease in the level, that level becomes constant. Why it happens? Because first at the beginning what happens, the water starts getting evaporated, then the
Yeah.
air what is there inside the closed container above the surface of water, that will get, after some time it will get saturated with water vapor. Okay, once it
Okay.
is saturated with water vapor, then the amount of water which is getting evaporated and the water molecule which are going to be condensed, both will be
Yeah.
same. That means a rate of evaporation and rate of condensation, rate of evaporation of water and rate of condensation of water vapor becomes the same. Then that situation, the pressure exerted by the water vapor present in the air of the closed container, that is nothing but the vapor pressure of water. Am I clear?
Yeah.
Understood or not?
Okay. Yeah. So the evaporation and condensation is equal to each other.
Yes, rate of evaporation and rate of condensation becomes equal. As you have studied in chemical equilibrium chapter, that rate
Yeah.
of forward reaction and rate of backward reaction becomes equal, then the
Yeah.
equilibrium composition remains constant. Similarly, here also it is a physical equilibrium because the process is
Hmm.
a physical process. So that then the level of water becomes constant. And at that point of time, the pressure exerted by the water vapor is called the vapor pressure of water when it is in equilibrium. Right? So
Okay.
that is what is the definition. Vapor pressure is the pressure exerted by a vapor in equilibrium with a liquid or a solid. It is applicable for solid also. That is why it is written on a solid. But here in this chapter, in when you are studying Raoult's law, then we will
Yeah.
discuss it with the liquids only. Our discussion will be limited to the liquid only.
Liquids.
So you can just make a note of it, the definition of the vapor pressure.